Okay, now let's learn how to write thermochemical equation. To write a thermochemical equation, you need to refer to the definition, and also you must label the enthalpy, positive or negative, and also kilojoule. Okay, now let us look at number 1, formation. Okay, usually we will use standard enthalpy of formation. Now let's look at my question here. Which is correct? Okay, we have 3 thermochemical equation here. The requirement is formation. Okay, so if formation, it must be from elements. And then the product must be 1 mole. Okay, let's look at the definition. The heat change when 1 mole of compound is formed from its elements in standard condition. Okay, thus, let us check thermochemical equation number 1. Okay, first of all, the product is 1 mole. Okay, first part correct. And then, are they elements? Okay, carbon, hydrogen, nitrogen. Okay, why do we have 3 elements here? Because if we look at the product, there's only carbon, hydrogen, and also nitrogen. So, the reactant part is also correct. And don't forget the phase. Okay, and then it is balanced. Okay, now we look at the enthalpy. Okay, let's see. Okay, it is heat change. Okay, so usually for enthalpy of formation, heat is released. So we must label negative. Okay, why the second thermochemical equation is incorrect? Because the product is 2 mole. So we cannot say that it is standard enthalpy of formation. Okay, the third equation is also incorrect. Why? Okay, one is because the positive sign is wrong. Another one is, although the product is 1 mole, but the reactants are not elements. CH2, ammonia, they are not elements. Elements must go back to the standard one, standard elements, like break down into the smallest: nitrogen, hydrogen, and carbon. Okay, now, next one, combustion. Okay, for combustion, we know that means that it must react with oxygen. Okay, both also react with oxygen. Why is it that the second thermochemical equation is correct? Okay, according to the definition of standard enthalpy of combustion, it says that heat release, and then you look at this, heat release means negative when 1 mole of substance is burned. Okay, so we look at the second equation. This is product. This is the substance that is burned in excess oxygen. So we have 1 mole of aluminium. And then the sign is negative, heat release, so it is correct. Okay, the first one is wrong because the substance is 2 mole, not 1 mole. And then 1 mole is, the sign is positive. Okay, absorb energy. So it is wrong. Okay, now we go to atomization. Okay, atomization, we have 2 equations here. Okay, why is it that the second is correct? Okay, now let's look at the definition. Okay, it says that 1 mole of gaseous atoms from its element. To form 1 mole of gaseous atom from its element, okay, so the gaseous atom is only 1 mole. Okay, and then it says that usually atomization, it requires energy, absorb energy. Okay, thus the first one is incorrect because the gaseous atom is 2 mole, not 1 mole only. Okay, and then one more thing, at standard state, bromine is liquid, okay, as element, not gas. Okay, now we go to the fourth one, enthalpy of neutralization. Okay, usually we will use the word standard enthalpy of neutralization. It says that heat release, okay, heat release must be negative when 1 mole of water is formed. Okay, So heat of neutralization or standard heat of neutralization emphasize on the heat release when 1 mole of water is formed. It's not about acid or base. So let us look at the equation here. Okay, again, the second equation is correct because heat is released and then the number of mole of water is 1. The first equation is wrong because the energy sign is incorrect, the enthalpy sign is incorrect, positive, and then the water, it has 2 mole. So it is not correct. Okay. Now, and then because when we use the word standard, so we put a note here. When standard enthalpy of combustion, standard enthalpy of formation. Okay, now we go to the fifth one, hydration. Okay, for hydration, it says that heat release, negative, when 1 mole of gaseous ion is hydrated in water. Okay, means from gas to aqueous. Okay, so let's look at the correct thermochemical equation. Heat release and then gaseous ion to aqueous ion. When it is hydrated, it becomes aqueous. Okay, the second one is incorrect because sign is incorrect and also the phase is incorrect. Now we go to the last one, enthalpy of solution or dissolution. You can use either one. Okay, what is the definition? The definition is the heat change when 1 mole of solute is completely dissolved in water to form a very dilute solution. Okay, so we have, the second one is correct because solute, okay, and then becomes solution. Okay, the first one is incorrect because NaCl is in aqueous. So in order to write the thermochemical equation, you must really memorize or understand all the definition of enthalpy. Okay, is it heat release? Is it heat absorbed? Then 1 mole refers to what substance? Is it reactant? Is it product? Is it water for neutralization? And then also you must remember, what is the phase for each enthalpy of thermochemical equation? For example, if solution, it must be solid to aqueous. If hydration, must be gas to aqueous ion. So there are many things that you have to be careful when you write down the thermochemical equation. So that's all for this part.